Now that we've looked at box and dot plots, we are going to look at double plots. So, a couple things to note. The reason that we use double plots, if we're looking down here, is we're comparing two sets of similar discrete quantitative data. So for example, if you have data from two different subgroups about the same thing, heights of sixth graders versus heights of eighth graders, salary of women versus salary of men. So they have something in common, but they're separate subgroups that we are comparing. Some things to note. From a dot plot, things that can be pulled from that data, you can pull all of the measures of center and all of the measures of variation. For a box plot, the only measure of center that you can pull is the median because we don't know the individual data values. And the measures of variation, everything can be pulled except the MAD because for the MAD, we need the mean. So first we're going to look at inferencing. So given a scenario, coming up with different inferences. The most important thing to note here is that there are tons of different answers that can be used here. So what I put down might be different than what someone else puts down. So the double dot plot shows the number of new emails in each of Pedro's and Annika's inboxes for 16 days. Compare the measures of center and variations and write an inference you can draw about the two populations. So when we are looking at this, we can compare anything. So we can look at the overall shape of the data. We can look at specific data points, up to you. Let's say I'm going to look at the overall shape. What I could say is looking at Annika versus Pedro, that Annika's is a little bit more spread out. So maybe Annika's emails are more spread out than Pedro. We can look at specific information from it. So we could say that, maybe we want to look at the median data value. So 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 1, 2, 1, 2. Okay, our median data value is 32 for Annika. I'm finding it for Pedro. So the median for Pedro is 34.5. So Annika, the median was 32. So we could even make a statement in an observation that the median emails for Pedro is 2.5 more than Annika. There's tons of other different things that you could say. You could say that, on average, Annika's emails are less than Pedro because most of the values are in these lower values. You could look at the range, you could look at the IQR, you could look at the mode, tons of different things you could look at. Second example, Casey surveyed students in her math and science class to see how many times they have posted a blog this month. Compare the measures of center and variations and write an inference you can draw about the two populations. So again, we can look at some general information. If I'm looking at the spread, they look relatively the same. The ranges are exactly the same, but maybe I'm just going to look at the IQR. So the IQR for the math class is more spread out than the IQR for the science class. So we could say the IQR for the math classes is more spread out than science. Another observation, we can literally just look at some values that are given. So maybe I'm going to look at the median value here. It's 20 for science. It's 10 for math. Okay? Or we can even just look at, say, the number of blog posts on average for science is more than math. So even not all values, but on average it is. Now let's look at some scenarios and observations already made for us and just determine whether they are true or false statements. So number 3, the heights of girls versus boys in Mr. Sapraga's gym class are shown in the double box plot below. Use it to answer the following questions. So the girls' heights were taller on average than the boys' heights. So we have the girls' heights here, the boys' heights here. That is not true. The boys' heights were taller on average than the girls' heights. Yeah, generally speaking, even though not every boy is taller than every girl, these values on average were higher, so that is true. The boys' heights vary noticeably more than the girls. Well, if I look at the range for the girls is 8, and the range for the boys is 8. And even the IQR, I think the girls is 5 and the boys is 4. That's really not noticeably more. So I would say that's a false statement. The median height for the boys is 5 inches more than the median height of the girls. So the boys' median was 69. The girls is 65.5. Well, 69 minus 65.5 is 3.5. So is that 5 inches more than the height of the girls? No, that's not true. Number 4, the top 8 finishers in the semifinal and final rounds of the 100-meter backstroke Olympic event are shown in the dot plot below. The swimmers had slower times on average in the semifinal round. Is that a true statement? What you have to remember is that we're talking about, the faster times versus slower times. So a higher number is actually a slower time. So the swimmers had slower times on average in the semifinals. So the semifinals, these higher numbers are slower times. Yeah, majority of them are here versus the majority for the final round are here. So that's a true statement. The swimmers' times vary noticeably more in the finals round. Well, we've got a longer range in the finals than we do in the semis, so I would say that's a true statement. All of the times in the semifinals are faster than the times in the finals. So every single semifinals is faster than the finals? No, that is not true. And then the mean of the semifinals is 0.4 seconds longer than the mean of the finals. All right, this is a little bit harder because we're dealing with decimals here. So you got to be really careful as we're adding this up. So we've got 56 plus, that's 56.6 plus 56.6 plus 57 plus 57.1 plus 57.2 plus, let's see, 5, 6, 7, 57.7 plus 57.9. So that equals 456.1 divided by 1, 2, 3, 4, 5, 6, 7, 8, which equals 57.0125. All right, looking at the semifinals. Adding up, being very careful. We've got 56.7 plus 57.2 plus 57.3 plus 57.3 plus 57.4 plus 57.5 plus 57.7 plus 57.8. We get 458.9 divided by 8. 1, 2, 3, 4, 5, 6, 7, 8 divided by 8 equals 57.3625. So I'm going to subtract the two. Semifinals is 0.4 seconds longer than the finals. So minus 57.0125. And I got 0.35. So if we are looking at, if it's at about, sure. But the exact amount, 0.35, is, I would say, false. If it's at about 0.4 seconds longer, true statement. And the last one. The double dot plot below shows the number of hours a class of students exercises each week to the number of hours the students play video games each week. So the students on average exercise more than they play video games. So do they have higher values for exercising than video games? No. The exercise times vary noticeably more than the video games. They're both pretty spread out and they both have outliers, so I would say no. All of the video game times are more than the exercise times. So is every single video game higher than the exercise? No. And then the median of the video games is 4.5 more than the median of the exercise. So let's find our median, crossing off lowest, highest, lowest, highest, lowest, highest, lowest, highest, lowest, highest, lowest, highest. We have two valleys in the middle. I'm just double checking. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the median is 2.5. Let's find it for video games. Lowest, highest, lowest, highest, lowest, highest, lowest, highest, lowest, highest, lowest, highest. The median here is 9. So we're doing 9 minus 2.5 equals 6.5. Is that true? No.